Hello.
Good evening, sir.
Yeah, good evening. Can you hear me?
Yes, sir.
Okay. So today we'll continue with where we left off in the last class. So the last thing that we did was Haruki's lemma in the last
And
class where,
butterfly theorem. Mm.
right, we have to do the proof of butterfly theorem.
Mm.
So we had seen this lemma which said that if you have two non-intersecting chords, AB and CD, AB and CD are non-intersecting chords in a circle. Then if you put a variable point P on the AB, arc AB, which does not contain C and D, then you say that E and F are intersections of PCAB. The intersection of PC and AB is called E, and the intersection of PD and AB is called F. Basically, the figure looks something like this. You have one chord here, AB, one chord here, CD, P is a point somewhere here, and PCAB, this intersection is E, and PDAB, this intersection is F. The lemma says that the value of AE times BF by EF is constant and does not depend on position of P. Right?
Yes,
So
yes, sir.
this is what we did, and the homework was basically try to prove Butterfly's theorem using this lemma. So it's a direct thing. Have you guys tried that?
Yes, sir, but I couldn't get it.
Okay. So
So I did from alternate way.
alternate way is fine, but we want to do it by this way because we want to use what we learn.
Yes, sir.
Alternate way is good, but ultimately you have to be able to use what we are learning. So the point was to try to prove it using the lemma. It's very easy by the lemma. Why did you look for alternate ways?
But actually, I forgot कि हमें लेमा से प्रूफ करना था. मुझे लगा कि हमें बस बटरफ्लाई थ्योरम थी.
तो वीडियोस को बाद में देखा जा सकता है ना. You can watch the videos again in case you don't remember what you have to do, right?
Sorry, sir.
Butterfly's theorem was saying that M is the midpoint of a chord PQ. M is the midpoint of a chord. Now through M, you will draw two other chords. One chord like this, one chord like this. These chords are called A, B, and C, D. Right? Now, if you connect A to D, that point is called X, the point of intersection here. And if you connect B to C, that point is called Y, right? So basically these points of intersection are X and Y. We know M is midpoint of PQ, and we have to prove that M is also midpoint of XY. This we have to prove, the second statement. This is given. That is Butterfly's theorem, right?
Yes.
So now think back to the figure that we had for Haruki's lemma. What was the figure there? Something like this. something like this, and we joined, basically we took a point P somewhere here and we connected it like this, right? P to this and P to this, right?
Yes, sir.
And we got that regardless of the position of P, this into this by this is constant, right?
Yes, sir.
Correct. So what you need to do here is think of, देखो, figure is so similar, right? There is one chord here, right? You can think of A as one position of P and C as the second position of P. Do you understand what I'm saying right now?
Yes.
यहाँ पे P को यहाँ से मूव करके यहाँ पे एक ला सकते थे ना ऐसे,
Yes.
right? So there are two different positions of P. A is the first position of P, C is the second position of P. Technically, this is the second chord, non-intersecting second chord in Haruki's lemma. Do you understand what I'm saying right now?
Yes, sir.
Yes, sir.
So focus for now on the point A. Think of it as the position of P in this lemma. So we can say that Px by MQ, Px into MQ by Mx is constant, right?
Yes, sir.
Yes, sir.
Px into Mx, Px into MQ by Mx should be same as for the second position of P, which is
P
C,
PM into
uh,
PM into
QY
QY
divided by MY.
by
by
MY.
My, right?
Hmm.
ये दोनों इक्वल होने चाहिए by Haruki's lemma, right? Now we also know from this theorem that M is midpoint of PQ. So we know that PM is equal to MQ, right?
Yes.
PM is equal to MQ. So यहाँ पे ये cancel out हो जाएगा, right? Correct. So we
Yes,
are
sir.
getting
Yes,
Px by Mx is equal to Qy by My, right?
yes, sir.
Now, what we will do is we'll add 1 to both sides to make it a better ratio. So we'll say 1 we have
Oh,
added. So it becomes Px plus Mx, right?
yes, sir.
Correct?
Now it's fine.
So it is
Yes, sir.
becoming Mp by Mx
Okay.
is equal to
Hmm.
Qy plus My, right? So
Yes, sir.
Mq by My, right?
Hmm.
और Mp and Mq तो already equal है. So we are getting
Hmm.
Mx is
Yeah.
equal to My.
Thanks, proof.
So this is why I wanted you to use this, because two steps only. You just need to use the configuration of Haruki's lemma, right?
Yep. Yes, sir.
So no matter what other method you do, this will be faster, right?
Hmm.
What I want you guys to do is to make good notes and see how we are building up concepts and we are using previous concepts in future theorems. That's how you learn configurations and that's how you will be able to master difficult problems. Is it clear what I'm saying?
Yes, sir.
So that's what you need to build up. Like build up your base of knowledge so that when a new thing comes, you have many tools to approach it with. So
Hmm.
the next point is criteria for perpendicular line segments. This is a very small thing and not very difficult to prove, but it is very important. You will see the benefit of this as we move along. So the statement goes like this: let AB and CD be two segments, and the good part of it is that they don't necessarily have to intersect also.
अच्छा
Not
मतलब they
necessarily intersecting. They could be separate lines in space also.
hmm.
Okay. Not
Yes, sir.
necessarily intersecting. Then AB is perpendicular to CD if and only if AC square minus AD square is equal to BC square minus BD square. So first of all, notice the structure of the statement. AC square minus AD square should be equal to BC square minus BD square. It's symmetric and easy to remember. Okay.
Hmm.
We are saying that two segments will be perpendicular if and only if this is true. Okay.
Hmm.
So think about it, try to prove it.
Okay, sir. Sure.
There is an easy proof using trigonometry and cosine rule. Think of trigonometry and cosine rule and all, and maybe you can get a easy way to prove it.
Hmm.
But we will do it in a slightly different way. So just take a few minutes to try it out a little bit.
Sir, how will we say if two lines are perpendicular or not if they're not intersecting?
Two lines can be perpendicular orientation, no, if you extend it and all. Like, like
Okay,
they don't have to, the segments are not intersecting. I don't mean lines. Lines were infinite length, right?
okay.
लेकिन सेगमेंट तो हो सकता है ना, कोई ट्रायंगल में कहीं पे एक सेगमेंट इस तरफ है, एक सेगमेंट कहीं और है.
Yes, sir.
If you extend it, obviously it will intersect. But even
Okay,
if
sir.
I had two segments which are separated and all, you can still, as long as you follow the correct order of this, AC square minus AD square should be BC square minus BD square here also,
Okay, sir.
if they are perpendicular. Do you understand what I'm saying?
Yes, sir.
So first prove, you can try to prove it for the simple case where they are clearly intersecting.
Okay, sir.
Sir, first proof is easy. Like we can use Pythagoras also in the first case.
You cannot use Pythagoras because we don't know it's perpendicular.
No, sir. If we assume that it's perpendicular.
That is obvious. That you don't have to do. Do the other thing. Assuming this, you have to prove that it is perpendicular.
Okay.
वो डायरेक्ट वाला चीज तो बहुत इजी है, उसमें उतना सोचने की नहीं है. Is anybody getting anything?
So please.
Okay, I will show you what we will do. So the solution that I will look at is not a trigonometry solution. It is slightly better because it is a more general solution which gives you some intuition. Also, it involves a locus type of problem that is also common in JEE. JEE exam में भी ऐसा आ सकता है. So this is a easy enough problem that some of it is useful even for JEE. So we can say that let CD be a segment in the plane then we are going to first prove that the locus of points P in the plane such that the expression PC square minus PD square is equal to constant. This locus is a line perpendicular to the segment CD.
So what is locus?
You don't know the meaning of locus?
No, sir.
Gitesh, do you know the meaning of locus?
Sir, it's something that generalizes
Hmm.
a motion or something like that.
Generalizes the motion of a point. If a point follows a particular path according to some rule, then that will be called locus of that point. For example, we can say locus of all points P which are equidistant from a fixed point. What is this?
Circle.
Is a circle around Q, with Q being the
Q.
center.
Hmm.
So basically, we are saying that if there are many points, or if there is a point P which moves in such a way that it's always equidistant from Q, right?
Hmm.
So obviously, it should trace out a circle, right?
Yes, sir.
So locus, the meaning of locus is that it's a path that a point P follows while always satisfying some condition. What is the condition here? That the distance
That
to
it is
Q is
equidistant.
fixed,
Hmm.
right? Similarly, I can say that the locus of points P such that the sum of distances of P from two fixed points is constant, that locus is an ellipse. You might not have seen the word ellipse or the curve ellipse before, but you will see it in 11th very soon, because coordinate geometry you'll learn all
Focus 1
this.
and focus 2. Yes,
So
sir.
this is one point F1 and one point F2. I want the locus of point P which moves in such a way that always the distance of this plus this distance plus this distance is always fixed, right? Basically
Hmm.
PF1 plus PF2 is constant. If that
So
happens,
sir means
notice कैसा मोशन होगा, ऐसे होगा फिर थोड़ा सा, right?
hmm.
फिर ऐसा हो, maybe it will cross here. It will trace
Hmm.
out a curve which is not a circle, it's like a flattened circle, right?
Hmm.
Orbit kind of.
It's like a planetary orbit with sun is here and all the planets are moving like this. So
Yes.
this is a curve which is an ellipse. So many such things you will see, many locuses you will see. So what we are saying right now is locus of points P which move such a way that PC square minus PD square is constant, right?
Okay. So that is a condition.
That's the condition that has to be always satisfied for point P. And you have to see all the different positions of point P where this is satisfied, right?
Hmm.
And that locus is a line perpendicular to the segment CD. That is what we want to prove, okay?
Okay.
Just like here, we got the locus being circle and ellipse. Similarly, in that case, the locus is supposed to be a line perpendicular to the segment CD, right?
Hmm.
So we'll show that first, and then we'll use that to prove our criteria for perpendicularness. So let's see how to prove this. So let's say that P is a point belonging to this locus, which means it will satisfy what condition? This one,
Hmm.
right?
Yes, sir.
Belonging to the locus. And let's draw a figure. So let's say this is my CD and P is somewhere here. And I know that P satisfies this condition, right?
PC square minus PD square constant.
Right. So it could be different positions. I don't know how it will be, where it will be, but I know at least whatever is BC square minus PD square here, it will be the same value for other locations of P also, right?
Hmm.
So from here, from this P, let's drop a perpendicular right now to the line segment and call this X, the foot of the perpendicular, right?
Okay, sir.
And what I need to show is that if the point X is independent of the position of P, of P's location. What is the meaning of that? No matter where I choose, देखो, if P was somewhere here or somewhere here as part of its locus, when you drop a perpendicular, the foot of the perpendicular will be different, right?
Hmm.
If it was any curve and all, then always foot of the perpendicular would be different, no?
Yes, sir.
But if the locus of P was a line, which is already perpendicular, right?
Okay. Then
Then
X.
obviously all the foot of the perpendiculars will be same X, right?
Yes, sir.
If the point X is independent of P's location, then P must lie on the line perpendicular to CD, right?
Hmm.
Is everyone understanding?
Sir, means we can only change the y-axis of px line, right? Not the x-axis, or the x position will also change.
What we are saying is that if P is a point belonging to the locus, I will drop a perpendicular from P to the CD line and I will call that foot of the perpendicular X, right?
Hmm.
Now, the only way P, the X location does not change is if the locus of P is itself a perpendicular line, right?
Yes, sir.
Yes, sir.
कोई भी और लोकस तुम बना लो, कैसा भी फिगर बना लो, any other type of shape also, depending on the different position of P, the foot of the perpendicular will obviously change.
Hmm.
Even if it's a line like this, foot of the perpendicular will keep changing, right?
Hmm.
The
Yes, sir.
only way foot of the perpendicular does not change, even if P position changes, is if that line is perpendicular. First of all, it has to be a line and it has to be perpendicular to CD.
Hmm.
Do you understand what I'm saying?
Yes, sir.
So, if the point X is independent of P's location, then P must lie on the line perpendicular to CD. That's what we are saying, right?
Hmm.
Now we will say it is easy from here now, because now what we will do is we'll calculate PC square. So let's see PC square by cosine rule here, right? It will be equal to, let's make a triangle like this. We'll say PDC triangle mein, it will be PD square plus CD square minus 2PD into CD cos PDC, right?
Yes,
Yes, sir. Cos PDC.
Cos PDC we are doing, and we are saying that PC square is equal to this plus this square minus, like cosine rule, right?
Hmm.
Similarly, we can also do PC square in an alternate way. Uh, ac- so actually, we are not doing anything else here. We are just rewriting the same thing, and we are saying this is equal to PD square plus CD square. But now what we will do is minus 2 CD we'll keep as it is and calculate what is PD cos PDC. PD cos
Yes, sir.
PDC. So that
XD.
is XD, right? Correct?
Yes, sir.
Yes, sir.
Great. So now see, from here we are getting PC square minus PD square is equal to CD square minus 2 CD into XD, right?
Hmm.
But we already know that P is a point belonging to the locus, so this part is constant, right?
Constant. So means CD is equals to
So if this part is constant, then this is also constant.
so constant. Yes, sir.
And CD is anyway a given line segment, so that is anyway constant, right?
Hmm.
So this also must be constant, right?
Hmm.
XD distance must be fixed, no then.
Yes, sir.
Regardless of the position of P, right?
Yes, sir.
Which means X is fixed, right? Because CD was fixed.
Hmm.
Do you understand that we have proved that P must
Proof.
lie
Hmm.
on,
Yes,
right?
sir. Hmm.
So basically, now that we know this, what we can say is use this condition on. Is everyone first of all understanding what we have done so far?
Sir, I understood that like we have proved that X is constant.
We have proved that X is fixed, right?
Yes, sir.
Regardless of
Hmm.
position of P on the locus.
Hmm.
So from there we have already proved that if X is fixed, then the point P must lie on the line perpendicular to CD now, right? According to our claim earlier.
Hmm.
So we have proved this statement now, right? This whole statement.
Hmm.
Is it clear to everyone? Gitesh?
Yes, sir. So, but why are we restricting X to a single point?
Matlab?
Matlab, why are we like fixing X? Like the PX can be any other straight line or any other curve also.
तो तुम basic point ही नहीं समझे हो. Aniket, can you explain what he is asking?
So like he's asking like why
No,
the
you have to
locus is
explain
straight
it to
line.
him.
Then why the locus is straight line instead of an ellipse or a curve? Because we just have proved that X is constant.
Okay.
नहीं,
But why are we saying that
किसी को
X
समझ
can
में
be
नहीं आया क्या?
anything? Okay.
Think again, and I mean, Aniket, it doesn't seem like you have understood also. If you have understood, you should be able to explain, right? You have to be able to explain it. I need some attempts at explanation. First of all, what we are trying to say is what is the locus of points P in the plane such that this expression is constant? We need to understand that locus. What we are trying to show is that that locus will be a line perpendicular to the segment CD. That is our objective. Gitesh, are you understanding what I'm saying?
Yes, sir, because it should be a line perpendicular to PH, I mean CD, then X should be a fixed point.
If it was not a line perpendicular to CD, the locus was something else. Maybe it was a curve. You
Then X is
understand?
not necessarily fixed.
Obviously, it will never be fixed.
Yes,
If it is anything else from different positions of P perpendicular on it will obviously be at different locations, right?
yes, sir. Because we're asking for a single line, then we want it to be a fixed point.
Basically, we're saying that locus of points which satisfy this, if it has to be a line perpendicular to the segment CD, then the X point has to be independent of the position of P. No matter where P is, X should be the same, the foot of the perpendicular on CD, right?
Yes,
Then only we can say that P is lying on the perpendicular line, right?
yes,
Correct?
sir.
Now, the second part of it, by cosine rule, we have written this relation, we have done this, and we have shown that because this condition is constant, we have shown that CD was fixed anyway because line segment CD was given. So from here we know that XD is fixed, right? And if XD is fixed, that means X position is fixed.
Yes, sir.
If X position is fixed, then that locus has to be a straight line perpendicular to it. No other locus will happen where X is fixed.
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
So now we are saying we have proved that if PC square minus PD square is constant, where CD is a given line segment and P is a variable point, then what we have proved right now is then P lies on line perpendicular to CD, right?
Yes, sir.
That is what we have proved so far. Correct?
Yes, sir.
Is it clear so far? Now look at the initial perpendicular criteria that we wanted to show. We wanted to show that AB is perpendicular to CD if and only if AC square minus AD square is equal to BC square minus BD square, right?
Okay.
So can you
Here
see
A is
that
P.
A and B are two different positions of P?
Yes, sir.
Two different positions of P where we are getting that PC square minus PD square. P के जगह A और P के जगह B. If you replace P with A and P with B, you get both are equal, right?
Yes, sir.
Do you see that it fits the whole condition here? We are saying that AC square minus AD
Okay.
square. is
Yeah,
equal to BC square minus BD square. That means both A and B must lie on
same line and
which line? It's a special
the
line,
locus of the perpendicular.
right?
Okay,
Do you understand what is happening?
okay, yes, sir.
The other ways are there to prove it by basic trigonometry and all. But this is a nice proof because it teaches you something about a locus also. And this type of question you will see even in your JE prep. What is the locus when this happens?
Yes, sir.
So we have used the locus property to prove this criteria. And it is a very important criteria. You should try to remember this. Okay. Is everyone following what I'm saying?
So means that locus simply means the path traced by a point.
Yeah. Locus means whatever path will, whatever points, whatever locations the point can be in so that that condition is satisfied.
Uh, at different times, it can be a different path.
For
Got it, sir.
example, locus of points which are equidistant from two given points. 2 points
Perpendicular
are given.
bisectors
So
or
that is a
nine perpendicular.
perpendicular bisector.
Hmm.
All of these points will lie on the perpendicular bisector.
Hmm.
Locus of
Got it, sir.
points which are equidistant from the two sides of a triangle will be on the angle bisector, right?
Yes, sir. Angle bisector.
So it's just a word that it is used to explain what path has to be followed so that some condition is always true. Right now we are saying locus of point such that PC square minus PD square is constant means P should be on a line
Perpendicular.
perpendicular to CD.
Hmm.
I hope everything is clear now.
Yes, sir.
And from there only we got two different positions of P are A and B. So we are able to prove that AB is perpendicular to
Uh,
CD if and only if AC square minus AD square
CD,
is equal to
BC
BC
square.
square minus BD square,
Hmm.
right?
वही मतलब A and B are different position of P at different time if
Yes.
we see. Hmm.
That
Okay.
is clearly satisfying the constant condition,
Hmm.
right? So this
Yes, sir.
criteria is very important. This is our point number 6 in our theory, the perpendicular criteria. Okay, now we'll go to the next point, which is a very important theorem again. It is called Carnot's theorem. So what is Carnot's theorem? So the statement goes like this: let ABC be a triangle and let M and P be points on the sides BC, CA, AB respectively. Then the perpendicular lines at M and P to BCCA AB respectively are concurrent if and only if MB square minus MC square plus NC square minus NA square plus PA square minus PB square is equal to 0. So try to understand the theorem statement first let's draw a triangle. We can take M and P as any random points on the sides. Okay. So you can take M as a point on the side BC anywhere you like. M
Hmm.
here. N as a point on the side CA, let's say here. And
Hmm.
P as a point on the side AB, let's say here, right?
Yes, sir.
The theorem is saying that we'll draw perpendiculars at these points, right?
Hmm.
Notice that right now they are not concurrent.
Hmm.
The three perpendiculars are not intersecting at one point, right?
Yes, sir.
Yes, sir.
The theorem is saying that it could be some situations, there could be that they are concurrent, right? The three perpendiculars.
Hmm.
The condition for concurrency is this. What is the condition? MB square minus MC square plus NC square minus NA square plus PA square minus PB square is equal to 0. So notice that there is a nice symmetric pattern to the whole thing. What is the
Ah.
pattern? You start from here, from any one place. You can select and put this as first also or this first also. That doesn't matter, right? You start from one point M, do MB square minus NC square, then you have to go to the next side and start with this first and then minus this, right?
Hmm.
And then you have to do this square first and then minus this square.
Minus X. Yes, sir.
I hope you are understanding the pattern, because if you make a mistake in the pattern, then your theorem statement only will be wrong.
Okay.
Hitesh, are you understanding what I'm saying?
Yes, sir.
The theorem is saying that these perpendicular lines will be concurrent if and only if this sum is equal to 0, right?
Okay, sir.
So what I want you to do is to prove one side of it. The other side will be homework. What I want you to prove is, if they are concurrent, prove this condition.
Okay. Okay.
If they are concurrent, prove the condition. The other side you can try yourself later. Other side would be, if the condition is true, prove that they are concurrent, right?
Yes, sir.
Right now, prove one side of it.
Okay.
Think of what we have learned so far, all the 6 points we have seen so far. Maybe something from there will help you. If you have made notes, you can refer to anything that we have learned so far in the previous couple of classes. ज्यादा पीछे ढूंढने की जरूरत नहीं है, अभी ही सीखा है जो पिछला क्राइटेरिया, उसी से हो जाए। पॉइंट नंबर 6 लिखा है तुम लोगों ने?
हाँ.
Sir, I will write it later.
अभी तक लिखे नहीं थे पॉइंट नंबर 6?
नहीं सर, बाद में लिखूंगा।
लेकिन कुछ तो लिखा
मतलब
होगा ना।
वीडियो, नहीं बस थोड़ा रफ कराना।
तो फिर अभी यूज कैसे करोगे? अभी ही भूल गए होगे अभी तक में।
हाँ वो थोड़ा सिमेट्री याद था मेरे को, वो ट्राई करूंगा।
Basically, point number 6 is the previous thing that we proved, criteria for perpendicular.
Yes, sir.
What is the criteria? AB is perpendicular to CD. क्या criteria?
Then AC square minus AD square is equals to
हो गया
BC
सर।
square minus
Hmm.
BD square.
सर
Hmm.
प्रूव्ड।
So if you use that criteria, it is very easy to do this.
ये सर प्रूफ सर।
So basically, you will say, let's assume they are concurrent, right?
हम्म।
So we'll say A, B, C. Let's assume that the perpendiculars are meeting somewhere. So let's say it was like this. M, and what was the names of the points? M and P, right? Right.
हम्म।
Yes,
M, N, and P. Let's say we have drawn perpendiculars and they are concurrent, and this concurrency point is X, right?
हम्म।
Then by the previous criteria, we know now that XM is perpendicular to BC, right?
हाँ।
So by the previous criteria, Gitesh, what can we say?
XB square minus XC square is equals to MB square minus MC square.
Correct. Similarly, XN is perpendicular to AC, right?
Yes, sir.
So XA square minus XC square is equal to NA
NA
square
square minus
minus
NC
NC
square
square. And
हम्म।
similarly, XP is perpendicular to AB.
therefore XA square minus
minus
XB square
XB
is equals
square
to PA square minus PB square.
PB square.
Then we will
Now
add these and then let's prove.
we will add these and it will become 0, right?
Yes, sir.
हम्म।
It is not becoming 0 because I have flipped the order by mistake. You should always write BCCAAB.
हम्म।
देख रहे हो क्या हो रहा है?
हम्म।
हर
Okay.
समय हम लोगों
सर
को कैसे
दो
लिखना चाहिए?
-2x ही हो रहा है अभी, -2x से
हाँ,
हो
लेकिन
रहा है
अगर
बस।
हम लोग सही से करते, सिमेट्री को मेंटेन करते हुए, राइट,
हम्म।
BCCAAB लिखते हैं तो यहाँ पे क्या आता है? XC स्क्वायर माइनस
Minus
माइनस
एक्स
XA
XA
ए
स्क्वायर
स्क्वायर, और यहाँ पे आता है
इक्वल्स
NC
टू
स्क्वायर माइनस NA स्क्वायर,
माइनस
राइट?
NA.
NA स्क्वायर।
So
हम्म।
now it would cancel out nicely, right?
हम्म।
Yeah,
Left hand side is 0. So what are we getting is 0 here. We are getting
yeah,
हम्म।
MB square minus MC square plus NC square minus NA
माइनस NA
square
स्क्वायर
plus PA square minus PB
माइनस
square is
इक्वल्स
equal
टू
to
0।
0, right?
yes,
And
हम्म।
that is proof of one side of Carnot's theorem, right? So
यस
we
सर।
are saying that if the perpendiculars are concurrent, this condition must be true. You should try to do the other side also, okay? But do it
यस सर।
later. Uh, is everyone understanding what we have done?
yes,
यस
sir.
सर।
Okay. Point number 8 is a question, but it also introduces a point known as Bevan's point in a triangle. You don't need to remember the names and all, but it has a name. So I'm just telling you the name. But the main thing is we will be able to solve a question like this. So the question is like this. Let A1, B1, C1 be the points of tangency of the x circles with centers IA, IB, IC of triangle ABC with the sides BCCAAB
हम्म।
respectively.
Hmm.
Okay. Then
Hmm.
the lines IA A1, IB B1, and IC C1 are concurrent. This concurrency point is known as Bevan's point. Concurrency point is called Bevan's point. What our problem is to prove that they are concurrent. This is what we have to prove. Do you understand the problem?
Yes,
Yes, sir.
Do you know the meaning of X circle? Everyone understands X circle, right?
yes.
Yes, sir.
Opposite
So,
to the side.
so this is A, B, C. I extend it, and this would be the X circle opposite to A, right?
Yes,
Hmm.
It is. It can be constructed by making angle bisectors of these exterior angles
Exterior angle.
and
Yes,
one
sir.
interior angle, right?
Hmm.
I hope everyone knows this because of SL only.
yes,
Yes, sir.
This center has been called IA here, right?
Which one?
And this point of tangency, notice that the point of tangency is not the same as the angle bisector line.
Huh.
The circle doesn't have to touch here. The circle is touching somewhere else, right?
Hmm.
The point of tangency of the IA circle with BC has been called A1, correct?
Okay.
Do you understand what I'm saying right now?
yes, sir.
Yes, sir.
Similarly, if you draw X circle, other X circles also, let's say one more X circle we draw. This is another X circle,
Hmm.
right? This will be the point of tangency with AB, and that is C1 basically, right? And this X circle is the center of this circle is called IC because it is opposite to the vertex C, right?
Hmm.
Are you understanding what I'm saying right now?
Yes, sir.
So the question has told us about the three X circles and the 3 points where the X circles touch the sides, right?
Hmm.
Okay.
A1, B1, and C1 are the 3 points where the X circles touch the sides,
Hmm.
correct?
Hmm.
You have to prove that the line joining IA A1, so this line, the line joining IC C1, and the line joining IB B1 are concurrent. And the point of concurrency is known as Bevan's point. That is your homework.
Yeah.
This is the homework. Write down the problem, otherwise you'll not know only what the homework is. If there is any confusion in what you have to prove, you need to ask me now.
No, sir. Not in the question. No confusion in the question.
Okay, so this is one thing, and another thing is point number 9, which is radical axis. You might have heard of this somewhere.
Only
So,
heard, sir.
so we have, I will tell you the definition. Given any two non-concentric circles
Hmm.
C1 and C2 with centers O1 and O2, with centers O1 and O2 and radii R1 and R2,
Yes, sir.
the radical axis is the locus of points P in the plane that have the same power, the same powers with respect to the two circles. So we have already done, this was the first thing that we did, power of a point, right? So radical axis is defined as the locus of all points which have equal power with respect to the two circles. I hope everyone knows what power of a point is.
Yes.
Yes, sir.
So radical axis is the locus of all points which have equal power with respect to two circles. Your job is to understand what that locus would be. What would that locus be? How will it look? Right? And okay, just tell me how would it look? And maybe whether I'm thinking whether I should say this one. Or I will just tell you what it is. We have to prove that the radical axis is a line perpendicular to O1, O2. What is O1, O2? O1, O2 is a line joining the centers.
Yeah.
So this is the question. I have given you the definition of radical axis. Use the definition, prove this. Is it clear, the question?
Yes, sir.
So that is point number 9. I want you to work on 8 and 9 for sure before Tuesday's class. 8 is
Okay.
Bevan's point, the previous problem, right?
Mm.
Make sure that you try it out for sure before Tuesday's class. Then only we'll be able to make progress. And use whatever we have learned so far. If you use it, you will be able to do it. It's not very tough actually. If you use what we have learned so far, you will be able to do it for sure.
Okay, sir.
Okay, fine. That's all for now. Yeah, that's about it. We'll continue with more theory in Tuesday's session.
Okay, sir.
Yeah, I'll see you next time.
Thank you, sir.
Thank you, sir.